Hello, everyone. So, today we're going to take another look at some of the angles that we can find in triangles and see if there's any interesting things we can find. So, if we look at this problem right here, it wants us to find the angle x. That angle is not in the triangle itself, it's on what's called the exterior of the triangle, the outside of the triangle. So right now, we don't know really much about the exterior angles of triangles, but in the last set of videos, we did talk about the interior angles of triangles and how they all add up to 180 degrees. So we could notice, okay, well, I have the measure of angle A, the measure of angle B. How about we find out the measure of angle ACB is? And I can do that by, again, adding the three angles of the triangle up and then setting it equal to 180. So 35 degrees plus 79 degrees plus angle ACB is equal to 180 degrees. Okay? So from here, it's, relatively straightforward. 35 plus 79. That would get us 114. We still have the angle ACB left over. And now we would just subtract 114 from both sides. Subtract 114. So we find out that angle ACB is equal to 66 degrees. So, okay, now we know what that angle right there is. 66 degrees. So, knowing that, well, if we take that 66 degree angle and combine it with the angle we see at x, we notice it makes a straight angle. And as we know, straight angles add up also to 180 degrees. So, x plus 66 is equal to 180. Subtract 66 on both sides. And we get x is equal to, well, we get 114. Okay, that is our answer, and that's pretty interesting because that's exactly what the two angles that we started out with, the 35 and the 79 degree angle, add up to. 35 plus 79 is also 114. So that's interesting. This angle on the outside is equal to the same value as these two angles added up together. So I wonder if that's a coincidence. I wonder if, that's just a one-off thing or not. Well, in math, we can try to prove it and show that maybe what we just found out works 100% of the time. So in this problem, we want to prove that angle x plus angle y is equal to this angle xzp right over here. That exterior angle. Okay. So basically, we're going to use almost all the same stuff we used in this problem. All the same ideas, just generalized. So let's take a look at what we got. Well, I want to prove angle x plus angle y is angle xzp. Well, what do I know about angles x and y? Well, again, there are two angles in this triangle, two interior angles. And the other thing we know that we have proven so far is that the three angles in a triangle, the three interior angles of a triangle, add up to 180. So we can make an equation out of that. Angle x plus angle y plus this angle xzy is equal to 180. Because the interior angles of a triangle add up to 180. Okay. All right, well, that's something. Now we have an equation in terms of x and y, but how do we get some way to relate it to the angle xzp? Well, again, look at what we did on the previous problem. xzp is the exterior angle. Well, the angle next to it would form a straight angle together because there are two angles on a straight line. That 66-degree angle over here. And then we used that, took x, set it equal to 180 with the other angle, and then found out what the measure was. So we can use that very same idea over here. If we just add the angle xzp with angle xzy, we know that that is also equal to 180. So angle xzy plus angle xzp is equal to 180 because they form a straight angle. Okay. Running out of room a bit, so let's scoot down. Alright. And this is really all we need to get to where we want. So we have two equations that are equal to 180. Angle x plus angle y plus angle xzy is equal to 180. And angle xzy plus angle xzp is equal to 180. And if two things are equal to 180, they must be equal to each other. So we can set the... Here, let me just mark it. We can set these parts of the equations equal to each other because we know that they are both equal to 180. So angle x plus angle y plus angle xzy is equal to angle xzy plus angle xzp. And we are almost done. We should notice that, okay, there's an angle xzy on both sides of our equation. So let's just subtract by that to cancel it out. So subtract angle xzy on both sides of the equation. What are we left with? Well, the xzy's are going to cancel out. So we have left over angle x plus angle y is equal to angle xzp. And that is exactly what we wanted to prove. Angle x plus angle y is equal to angle xzp. We can take a look, right? There we go. Exactly what we wanted to prove. So, since we didn't really assume any values or anything, we have generalized this problem, which means now we can know absolutely for certain that This exterior angle, XZP, is equal to the sum of these two angles on the interior, but on the opposite sides of the exterior one. So those are called remote interior angles. Now let's just get to the proper, definition. So angle X and angle Y are called remote interior angles of the exterior angle XZP. So it doesn't really, the name itself doesn't matter. Just think of it as if you have the exterior angle of a triangle, like here, look at the two interior angles not connected to it, this one and this one. The sum of those two angles is equal to the exterior angle. Or usually this is stated as any exterior angle of a triangle is equal to the sum of its remote interior angles. So just another handy triangle theorem relating its angles. We'll use this to solve a couple problems down the road. It's just a handy fact to know, but honestly, like, if you understand, like, the logic of it, it's not really something you have to memorize. The important part is just understanding why this is true. If you understand why it's true, that means, even if you forget the specific details, you forget what a remote interior angle is, you still can understand the idea of it, or potentially how to figure out or understand the idea of it if you're a little hazy on it. But that is that. I will see you in the next video.